Bioplastics, more accurately known as bio-based polymers, are plastics derived from renewable sources of biomass. They can be made from agricultural byproducts, food waste, vegetable oils, fats, sawdust, like plant product, so on and so forth. There's a lot of stuff you can make bioplastics out of. If it's living, you could probably do a little bit of alchemy, turn into some plastic. There's a lot of types of bioplastic from a lot of different sources. They all got different properties. Some are strong, some are moldable, some work like epoxies, some biodegrade to different extents than others, and some are just better. There's some not good bioplastics out there. But before we get into the details of our favorite bio-based polymers, let's discuss the issues with normal plastics. Part 1. Plastics. Conventional plastics. I'm gonna say it. We got too many of these damn conventional plastics on our planet, and that's just not okay for quite a few reasons. For one, we all know the classic issue with conventional plastics, is not being biodegradable. They only really break down with UV radiation, so you're thinking, gee, what's the issue if it still breaks down? The issue is that when conventional plastics break down from UV radiation, they just break into little smaller bits of the same material. This means that, over time, microplastics seep their way into the environment. They poison all kind of ecosystems in the soil, and they even turn the ocean into like a thick plastic soup. That's why you can't just scoop all the plastic out, because it's all these tiny particles. All the fish are eating them and breathing them, and this is in opposition to the way something breaks down. And when it is biodegradable, when something's biodegradable, it breaks down into biomass, water, carbon dioxide, and possibly a few other materials that are safe for the environment, a couple trace metals perhaps. You're thinking, well, damn, like, why don't we just recycle all the conventional plastics? My plastic, my McDonald's cup for my McFlurry right here that I have with me right now, that I keep on me, as a little recycling symbol. So, like, whatever, right? No, with the vast majority of conventional plastics, they are difficult to recycle, or you just can't recycle them whatsoever at all. Those little recycling symbols with the number in the middle on plastic packaging don't mean that they're recyclable. It tells you sort of a little information about its recyclability. So, for example, if it's the recycling symbol, it's got a little number 1 in the middle. That means it's polyethylene terephthalate, which is recyclable, but only about 30% of it is recycled each year, and that's one of the most recyclable plastics. Only 30% for the most recyclable plastic. That's pretty bad, not good. And then furthermore, if it's the little recycling symbol on your McDonald McFlurry cup, and it's got the 3 in the recycling symbol, it's polyvinyl chloride, which is barely recyclable at all because of how just toxic it is. Even worse, if it's got a 6, it's polystyrene, which you pretty much can't recycle whatsoever at all. So that's all bad. And just to add on to it, conventional plastics are made of oil and natural gas, non-renewable fossil fuels. And since we can barely recycle this at all, then, making it out of non-renewable resources is bad. Like, we have a limited amount of possible conventional plastic. And not only that, but our dependence on oil is already a huge, geopolitical issue, and it causes all these conflicts, and I am sick and tired of invading Iraq. I don't think 3's a charm on this one. Part 2. Well, if plastic is so garbage, if conventional plastics are so bad, then what's even the point? Why do we use them in the first place? Why don't we just get rid of plastic altogether? Well, all materials have different characteristics. There are many kinds of plastic, but overall plastic is notable and important in that it is lightweight, flexible, insulative, non-reactive, pretty strong for its weight. And this is all pretty cool. This has allowed plastic to be used in many different applications, but most importantly, plastic is very cheap and easy to manufacture in large masses, especially because of a manufacturing process known as plastic injection molding, which allows for high volume of relatively complex polymer parts to be manufactured for very, very little cost per unit. It's very beneficial It's very beneficial, and that allows for, little affordable products to be made for many applications, and, little plastic parts that go everywhere, and it's fantastic. It's very efficient. So plastic's cool in its utility and its manufacturing, but the environmental consequence is impossible to ignore. It is not, it's not a good balance. I love efficiency, but it's pretty bad, not good. So what's the good solution? How do we keep these plastics without destroying the planet? The answer is bioplastics. Part 3, bioplastics. I'm sure you figured out that this is all about bioplastics. I mentioned it in the beginning. These polymers, bio-based polymers, are made of biomass, so they have quite a few advantages over, fossil fuel-derived polymers, since they can be made of renewable resources. We aren't reliant on drilling for oil or natural gas for our fantastic plastic. We got all this damn, corn surplus and food waste anyway. Might as well do something with it, We can't fertilize with all of it. People pouring milk out everywhere. I mean, damn. Bioplastics are also doing way better on the biodegradability scale than conventional plastic. We're not at the point where just every bioplastic can be thrown in the dirt and break down, but we are getting there. Many bioplastics can biodegrade as long as certain criteria are met in terms of temperature, surrounding soil composition, and moisture. Others have to be broken down in an artificial composting process, but that's still significantly better than recycling. It's way easier, and it produces some useful compost, so that's pretty cool. Bioplastics also very closely mimic the current conventional plastics. Some of them mimic conventional plastics very well. And they share a lot of the same properties we know and love, so they can be used to manufacture products by molding it or forming it into shape. There are even some being developed, and some that have been developed, that can be used in polymer injection molding that we just talked about, which is a fantastic process. I love it. One of my favorites. So we've got all these different bioplastics. Let's talk about them. There's a lot of different properties and how they're made. So we've got impregnated wood. It's kind of sort of not a bioplastic. It's one of the earliest ones, if we consider it one. It's pretty much when you take wood and literally it's called impregnating it with sort of a resin liquid that usually uses formaldehyde as a base ingredient, and then a vacuum chamber is used to distribute the resin within the wood, and it makes it, more stable and more resistant. And that's cool and stuff, but it's really only found specific uses in construction and in your wood floors and in decks. They aren't really flexible or lightweight or strong, and they aren't very recyclable or biodegradable, so they just barely count. They're kind of an honorary bioplastic. There's one called Galath, really early bioplastic, invented in the late 19th century. And it's produced out of formaldehyde and cow's milk, that's cool. We got a lot of that. It's resistant to water and fire. But most importantly, it was actually pretty biodegradable. It caught on pretty quick for different consumer product applications, like making buttons and sort of faux jewelry, little things like that. But it couldn't be used for much more, since large objects made of Galath. No, Galath. Am I pronouncing? No, it's Galath. It's Galath. It tended to, Galath formed cracks and splinters, and it would warp over time when it was too big, and it wasn't very moldable once it was set, so you'd have to manufacture it into these large sheets and then cut those into shape. And that's less efficient than the molding we're used to today. So it was a good step, but it fell out of favor. Cellophane, 1912, big success. Here comes the money. Cellophane is made from cellulose of plant matter, such as wood pulp, cotton, hemp. It's pretty biodegradable, actually, and it's made into these very thin sheets. It's pretty common to this day. They use it to make scotch tape and some different food packaging. It's good for that because it has low permeability to air, oils, greases, bacteria, and water, but it has high permeability to water vapor, which isn't good for some of these applications, making it unusable in certain situations. It can be remedied by coating cellophane in nitrocellulose, which is used in gunpowder, but that's pretty toxic. Nitrocellulose is not good for you. So it kind of ruins the whole biodegradability thing, because if it biodegrades, now we just have this toxic chemical everywhere, so that's not good. Also, production of cellophane uses carbon disulfide in its production, which is pretty toxic to workers and contributes to pollution, so that's not good. Man, there was a little while where there just wasn't a lot of bioplastic development. So I'm gonna bust through these real quick, lightning round. Between you know, about when cellophane was cool, and then until the environmental movement, this is all we got. One, bakelite. A resin called bakelite can be combined with plant material to create plastic sheets that can be molded and formed into shape. Cool step forward. This is only ever used in commercial products like radios and had a weird detour in being used in